Hi, fifth grade. Today we're going to work on some math. So I need you to grab your fifth grade math home review packet. And we're going to continue in day 9. So we're going to be on this page for day 9. All right? Okay. Grab your pencil and let's get started. Day 9. Question 1. Which of the following numbers are prime? All right, guys, so at the beginning of the year, we learned about prime numbers and about composite numbers. Over here, I've got the definition of a prime number. A prime number is a natural number other than 1 that has exactly 2 different factors, 1 and the number itself. That means there are only 2 numbers you can multiply to get that number. 1 times itself. So a couple things we learned earlier this year is that all even numbers except for 2 are composite. So that means they're not prime except 2. And then all numbers that end in a 5 or a 0 are composite, which means they are not prime. So when you count by 5s, 5, 10, 15, 20, and so on. So now what we need to do is we need to go through all 9 of these numbers and see if we know any of the factors that equal these numbers. Let's start with 27. This is when knowing our multiples is really important. Knowing all of our 3s and 4s, 5s, all the way up to 9. What do we know about 27? Well, we know 27 times 1 equals 27. But if there is another number or more numbers that you can multiply to equal 27, then it is not prime, it is composite. Think for a couple seconds. We know that 9 times 3 is also 27. We know if we skip count by 9s, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27. So this right here proves to us that 27 is composite, not prime. It has more than 2 factors. So I'm going to give a big X on that. Let's move on to 68. Well, if we look over here, what do we know about all even numbers? We know that all even numbers are composite. And what is 68? It ends in an 8. Yep, it's even. So we know 68 can't be prime because it's even. All right, what's our next number? 36. What do we know about even numbers again? They cannot be prime. They are composite. And 36 is even, so it is composite, not prime. All right, let's head on up to that 9. We know 9 times 1, 9 times 1 equals 9. 9 is odd, so it is not even. It doesn't follow this rule. And it doesn't end in a 0 or a 5, so it doesn't follow this rule. So we need to see if there are any other factors. Are there any other numbers that you can multiply to equal 9? If you said 3 times 3, you are correct. So therefore, this right here proves to us that 9 is composite. It is not prime. Okay, let's go on to 54. What do we see about 54 here? It ends in a 4. 54 is then even. So if it's even, it's composite, which means it's not prime. All right, the next number is 2. 2 is even. So let's go over to our even rule where it says all even numbers except for 2 are composite. So does that mean 2 is prime? Well, let's see. We know 2 times 1 equals 2. Are there any numbers you can multiply to equal 2? What if I did 1 times 1? No, that equals 1. That can't be right. What about 3 times 1? No, that equals 3. So there are only 2 numbers to equal 2. So they have 2 factors, 2 and 1. So the number 2 is our first prime number here. All right, let's go to the next number. We have 43. 43. All right, so we know 43 times 1 equals 43. Now, this is when you need to get your multiplication facts out. Maybe even grab a calculator and test it out and tell us, is 43 prime? Are there any numbers that go into 43 to make it composite? Well, we know 43 isn't even because it ends in a 3, so it's odd. We know it doesn't end in a 5 or a 0. So after going through your multiples, you will find out that there are no other numbers you can multiply to get to 43. 43 only has 2 factors. So what that looks like is this. 43, if you made a factor tree, only has 2 factors. You can only have 43 times 1. That would be its complete factor tree. So 43 is going to be our next prime number. All right, we're on to 13. We're going to move a little quicker through these. We've got 13 times 1 equals 13. It's not even. It doesn't have a 0 or a 5. And there are no other numbers that you can multiply to get to 13. So 13 is going to be our third prime number here. All right, our final number is 81. Really think back to your multiples. Think about your multiples of 9. We know 81 times 1 equals 81. We also know that if we skip count by 9, we end up getting 9 times 9 equals 81. This shows us that 81 has more than 2 factors, and so it is composite, not prime.